How to build predictive baseball stat models. Imagine having the power to forecast how a player will perform or which team might win a game before it even starts. That's what building predictive baseball statistical models can do for you. It's like creating a crystal ball using numbers and data. The first step is to clearly define what you want to predict. Are you aiming to forecast a player's batting average, the number of home runs, or the outcome of a game? Knowing your goal helps guide the entire process. Next, gather your data from reliable sources. You want a mix of historical and current player stats. This includes traditional stats like batting average, on-base percentage, and slugging percentage. But also consider advanced metrics like wins above replacement, which estimates a player's overall contribution compared to a replacement player, and isolated power, which measures a hitter's raw power. For pitchers, stats like walks plus hits per inning pitched are useful. Don't forget situational data such as whether a game is played at home or away, rest days, or player injuries. Data sources include Major League Baseball databases, Statcast, and historical records. It's important to clean this data by fixing missing values and making sure everything lines up correctly. Once your data is ready, pick the right features or variables to include. For example, if you want to predict game winners, features could be team batting averages, starting pitcher stats, recent winning streaks, or even weather conditions. You might also create new features by calculating rolling averages or weighted metrics that reflected recent performance trends. Feature engineering helps your model understand the data better. Now, choose a modeling approach suited to your prediction goal. For binary outcomes like win or loss, logistic regression is a simple yet effective choice. For more complex patterns, machine learning algorithms like random forests or support vector machines work well. Bayesian models are also useful because they incorporate prior knowledge and give probabilistic results. Sometimes, you might use weighted likelihood or semi-parametric Bayesian methods to handle sparse data or borrow strength across players. Training your model involves feeding it your data and testing how well it predicts unseen data. Techniques like cross-validation help prevent overfitting, which is when a model learns the training data too well but performs poorly on new data. Regularization methods like elastic net can improve the model's ability to generalize. Evaluate your model using accuracy, precision, recall, or the area under the receiver operating characteristic curve, depending on your prediction type. Advanced techniques can boost your model's performance. Markov Chain Monte Carlo methods help estimate posterior distributions in Bayesian models. Clustering can group similar players or game situations to improve predictions. If your data has imbalanced classes, like fewer instances of rare events, oversampling can help your model learn from those cases. Finally, interpret your model's results to see which factors are most influential. Use these insights to make predictions about upcoming games or player performances. Teams can use these models to plan strategies, develop players, or make roster decisions. For example, you might predict which pitcher is likely to give up the most hits or forecast a batter's future home run count based on past trends. Building these models is a process of combining data, statistical methods, and computational tools. It's about turning raw numbers into useful predictions that can help you understand and anticipate baseball outcomes. By carefully selecting data, engineering features, choosing the right models, and validating results, you can create powerful tools to analyze the game across different eras and situations.